I am very happy to introduce our second speaker, Mr. T. Ranjithraj. He has completed his BTech degree from Annamalai University in the year of 2009. He joined as trainee in Hexaware in 2010. He worked on multiple projects in research and development. Then he moved to Pramati Technologies. At present, he is working as software architect in Cisco Systems Chennai. He is a multifaceted person as he is doing psychology currently. I kindly invite you to give your tech talk, sir.
Thanks a lot. Okay, I hope I'm audible. Let me start my share.
Yes, you're audible.
Thanks a lot. Let me share my screen.
Yeah, sure.
Can you see my screen?
Yes, it is visible. You can go ahead, please.
Yes. Okay, let me. I'm facing some technical difficulties. Give me 2 minutes.
I kindly request the rest of the participants to mute your audio. Mic, please. Yes, sir, you can start, please.
Yeah, sure. Okay, thanks a lot for joining here, and thanks for Saram and Subaladita for giving this good opportunity to interact with you all. I'm happy to take your questions at the end of the session, and also you can have a chat. You can all your questions. Let's discuss more about what is reactive programming. Right? Okay. Okay, what agenda I have? I have agenda of what and why about reactive programming, and reactive on application level and reactive on system level. So very short agenda, but I have many slides to share with you all. Okay, some prerequisites I expect some here, like basic programming. If you know what is for loop and if conditions, that's enough for this session. Also, if you know concurrency, that's well and good. You will be gaining more out of this session. So what is concurrency? Today, everywhere, it's a multi-core, multi-computer, distributed computing, right? It's all coming under concurrency. If you understand how a single data is retrieved from multiple systems with the concurrent threads and implementation, right? That's what concurrency. If you're not aware of concurrency, yes, it's okay to have here. It's not hard and force that you should have that, right? It's not mandatory, it's just a recommendation. Okay, end of the session, you're all going to get something about reactive concept, how to implement reactive programming using readily available frameworks. So these frameworks are so mature. When I started 4 years back reactive programming, there was very less books at all. Right? So now it's so matured place. Everyone can explore after this talk. That's the end of the session you're going to gain. Right. So definition of reactive programming, right? Reactive programming is a declarative programming paradigm concerned with the data stream and propagation of the change. That's from the source wiki. Let me go with a simpler terms, right? So to make more understandable, program with reactive programming is easy when you know how to use it, right? So program that reacting for the event and changes. So what event and change, right? So if you consider there are friends other side of the world who is posting something on Twitter, that change or that event is propagated to your mobile as a friend's feed, right? That's what the event and the change. Okay, asynchronous model. You are not waiting when your friend is going to post something, right? You are moving and you are doing something asynchronously. Your data is received at your mobile. So that's asynchronous model. And stop blocking threads. It's very simple. Current model of programming, right? What we do is like a single threaded model. If you are working, you are blocking your thread to accomplish some task. So in this reactive programming, we have to stop blocking the threads. And to attain more concurrency with a smaller number of threads, utilize resource maximum. How far you can go, right? You have a 8-core processor, you have a cloud computers, and you even mobile, we have a 8 GB RAM. So, sorry. Okay. So there are hardwares are improving, right? So we can maximum utilize this resources by having reactive programming. And order of instruction.
Sorry to interrupt you, Mr. Ranjit sir. Like the slide is not in the slideshow view, I guess.
Okay.
What
yeah.
do you? It's now perfect. Yes. Sorry for the interruption. Yes, it's perfect now.
Okay.
Yeah, you can go ahead, please. Yeah.
Okay. Thanks a lot.
Yeah.
What do you see now? Do you see only my browser or anything else you are seeing?
Yeah, we are able to see your slides. Yes.
Okay. Thanks a lot.
Yes.
Okay, fine. So what, right? So I was just telling you what reactive programming it is, right? Okay, now let's move on where it is being used now. So stock market apps, feed processing, and real-time editors, right? So where the Google editors, Google Slides, Google Document. Okay, so these all are some of the example how where the changes are propagated and you can receive at the receiver end. Okay, why reactive programming is needed? Classic three-tier architecture does not fit now for recent style of internet usage, right? It means like even it was said by Gartner in the year of 2013 that three-tier architecture no more for the future. And game changer is like advancement in hardware. Microservice architecture is the key on this reactive programming and internet, right? So internet is there everywhere. Almost, it's not completed, but it's there everywhere, right? People are more utilizing internet now. And internet of things, if you consider, there are IoT and or we used to say in Cisco internet of everything, right? So these IoT or IoE are sending data every seconds to the server. So that's maximum usage of the internet. And live data flow, even Twitter or the stock market, what we discussed earlier, it was all a live stream of data. Okay, as I was discussing something on the previous slide, it's some more extended version of that. We have earlier we had multiple nodes, like monolithic application, 1 or 2 nodes we were having, but now we have many, right? Many microservices are deployed, and even if you consider how cluster are maintained, it's more, right? So response times are now in a milliseconds. Previously it was like seconds, now it's a milliseconds. And even data, right? Data, terabyte of data previously, now it's a petabyte. It's moving more than petabyte. And the latency or throughput, everything is talking in simpler application. And scalability perspective, right? So there is very less downtime for applications. Okay, so what is properties of reactive programming? So properties of reactive programming are responsiveness, resilient, elastic, event driven. That's a manifesto of reactive programming. Let me go detail into each and every properties here. Okay, I was in MCC during my college studies. I would like to take that example here, how we can achieve these 4 manifesto with the help of the NCC cadet, right? I was a NCC cadet. So next, right? So when my superior, right, the commander, right, or the lieutenant, when they are asking for any command, right? So if they are giving any commands, then I cannot be silent, right? I have to respond them immediately by making salute, right? So that's giving you responsiveness. How it can be correlated between our software industry. When your customers are using your application, you cannot say, hey, I'm loading your data, please wait, right? Or you cannot show them infinite progress bar, right? Still I'm loading. That's what the responsiveness. Give them something, right? So that's what explains this slide. And next slide is resilient, right? Resilient is something like how quickly you are recovered from the failures, right? So that I can give an example from the same cadred life, my college experience. When I was going in a march past, if we missed any steps, right, we are out of sync between the beats and our march past, right? What we do is like we do a fast walk or fast tap, then we'll be synced with the other step. So that's something like when you feel a failure, how quickly you are coming, right? That's a resilient. Elastic, right? Okay, let's move on to elastic. Elastic is something responsibility people are taking in the cadet life again. So when my commando or someone lieutenant said like go and dismiss, right? The parade is dismissed. Then we used to go and collect all our vessels and the properties what we brought. So there is nothing like he do that and he do this, right? So rather we take our own responsibility to do it, right? That's like when we are having our the tent, right? So or we have to dismantle it. We take our own responsibility to tie the rope or fold the mat, all these things. So this is something called responsibility. Elastic means a scalability. When your customer is coming, he's running $1 million or what is that? Sorry, in Amazon, like Indian sale, great Indian sale, right? That day you are getting huge amount of requests. How you going to scale? How you going to expand your application for customer need? That's the elastic. Event driven. Next, right? So event driven is a very simpler one. It was there for from humans decay when we started speaking, right? How human interact by speaking, right? By telling the message to someone, hey, can you move, right? So you are not asking them, hey, can you move? Then you are waiting him to respond, right? He'll be doing something, then you know that he moved, right? So this is something asynchronous communication. So similarly, that is mandatory in this new era of software development. Okay, let's move on to next slide. So these 4 properties are jumbled here. Let me try to connect on the next slide. Yes. So event driven is the underneath, right? It's a baseline. From there, you have elastic, resilient, and responsiveness. Okay. Imperative versus declarative. This is programming paradigm. I was explaining what is reactive programming all about, right? So this imperative or declarative or another programming paradigm we were using so for a long time. So under imperative, we have a procedural, object-oriented, like procedural, you can take C, object-oriented, Java, or C++. Declarative or something called functional programming or reactive programming, right? So functional programming, you know, Scala or, you know, Lisp, right? So, or Haskell, these are some of the language which support functional programming. Reactive programming, I'm going to talk in more detail next page. Right. So what is imperative versus reactive, right? Imperative means you have an instruction C equal to A plus B. Once this instruction is executed, that C value is already computed. If you are changing value of A after the computation of this instruction, you are not going to get those latest change, A's latest change recomputed by A plus B into C. This is something imperative. But in reactive, whenever you do change on the A and B, that's kind of an event, right? You're changing something on the A and B, update event. That event is propagated to the operation called plus, right? That is the function. Then the result is recomputed, or result is stored in C on the fly. Okay, where you see this one, right? So all I said like about reactive programming, it's not at all a new programming paradigm, right? So people brought this into picture recently because of the latest changes happened on other environment. Reactive programming is combination of other things, right? So if I say like reactive programming was an old idea, then where we have used earlier, take an example of an Excel sheet, right? When you have a cell B and C, or A and B, then C column or C cell will be computed whenever the value changed by A and B. This is something, the real example of how reactive, how changes are propagated to the value. Okay, now what is stream? I said changes, right? Changes means it's infinite. You can do the changes on some entity or some point, right? Many times. That changes are called event. Those events are streamlined. You can have a error event also, and there is a data event. If you have a mouse in your laptop, what you click on every minute, that computer consider that the events of a stream. So when there is a stop, that a computer can say like, hey stream, please stop, I'm no more going to listen. That's what this line is, right? You can stop a stream, you can consume a stream, you can process the stream. It's all about stream now, right? So if I stream, who are the actors for the stream? There is two: publisher and subscriber. Okay, there is a typo here. Obviously, as the early session by Radhakrishnan was telling about source and sync, right? It's a different terminology what I used here, publish and subscriber. It's all stream now. Okay, to more elaborate what is stream, if you think about the FM radio, they are telecasting their data, right, into the stream radio waves. So everywhere, everyone, what people are started listening their radio channels or their receivers into the stream, they start listen. If any one receiver going away or shutting down their receiving end, it's not mean that the FM station is stopped relaying, right? It's not mean. And there is a new connection comes in picture. So people are still listening to the stream. Think now it is the same. When you see Twitter feeds, you are not only the listener, right? There are many listeners. It's all stream. I'm stretching this word again and again to just give a note on. Okay, so this end shows that a stream, I stop listening to it. Okay, so I have a stream, data, right? Data stream, event changes are propagated as a stream. What I can do, right? I can filter my stream. If you say the stock market, I have I always curious to see what Cisco's stock market it is, right? So what I do is like there are many companies are there in the stock market. Their every data, their changing of stock values are streamlined here. But I only filter when the Cisco the data change, right? So that's how you can filter, and even you can map, right? When the data is in some different format, you can convert to an Indian format, right? When it is in a dollar, you can convert to a rupees. That's what the map it is. So similarly, you can apply many other functions on the stream. Okay, this slide is talking about some more functions like map, flat map, filter, reduce, and etc. Right? So if you guys are very new to this streaming, I would like to call out a Java 8 feature. Java 8 has something called a stream, where you don't need any more for loop to iterate your data. If you have an array, you can convert array into a stream where you can apply any of these functions into a stream, right? So that's easy. But now, let me explain how we transformed to a reactive programming from concurrence, right? So in Java, I'm just taking Java here example because it's well known for everyone. Even Python is there, but I'm just taking Java here. So if you heard about threads, that's where we started writing concurrent programming. Later, we got something called the future, right? You don't want to wait, or you can say like you want to get some data out of this thread. What you do is like you got something called a placeholder called a future. Whenever the data available, this future will be filled. Consider it is a bucket where you are giving to the grocery shop guy. He will fill the value when his employee done filling the groceries, right? Similar one is called future. Okay, then why I need some completable future, right? When that grocery shop guy is filling it up, right? I said like, hey, you are taking too much time. I'm going for looking for a next job, next shop. He will not allow me to go. He will say like, I filled it. I'm filling it. Please wait. That's what the future it is. But completable future says, hey, I'm done. Come out, right? You can complete your future. And next is a Java reactive stream. Now, you are not waiting in front of the grocery shop where you are telling the shop guy to deliver to your home, right? You're saying like, hey, I need this one by communicating through message. And the guy going to deliver to you your home when the data is ready, when the grocery items are ready. That's the simplest example I can give for concurrency to reactive in Java. Okay, that said, some of the picky, we may need some lead on what is a future it is. This explains the definition. Future is a placeholder to get a response from the callable. It's the simplest code. I have order, right? Consider this, right? This item is a order. Order has a blue cone, red cone, and gray cone. It's an ice cream parlor who got 3 different cone order. Now, execute a service something there in the Java to handle threads in a finer way than thread class do. So I have a 5 threads in a thread pool. Whenever this order comes here, or I'm iterating it with this list, I'm submitting my order into here. Consider I'm going some IO operation. Okay, picking the chocolate toppings, all these things, right? And that's an IO operation, input output operation. So that may take time. So I have here 2000 milliseconds. So after that, it's going to return. This is the problem when you are saying result.get, right? The customer saying like, give me item. He's still waiting. I'm blocking here. Not only blocking him, I'm blocking all other threads. If I have some more new order, I cannot process that because this result.get is already blocked my thread. No more input I can receive. That's a blocking operation. So callable, as I said, like explicitly you can complete. That's the definition says here. So completable future, we have something similar cone items in the ice cream parallel order. What different it is, I'm not waiting till my first order been completed. I'm doing completable future dot supply async. So the completable future provide the first entry to the async world. If you know the JavaScript, yes, JavaScript has asynchronous already, but Java you can write asynchronous by bringing your own threads implementation, right? But here This supply async is just a method which is accepting some supplier or method or function to do operation. So pick cone, if he's going to pick some cone, he will add the flavor, decorate, wrapper, deliver. No matters what operation on the first cone it is the customer or the service is doing, this it will pick the next red cone. So that shows how completable future occupied, right? The entire Java industry by Java 8. Now, reactive extension. Reactive extension, yes, it's been there for at least 4 to 6 years, right? But now it is future, right? Who are all the frameworks provider? Okay, if you see here, I made it as an extension. Why it is extension? When I talked about functional programming and reactive programming, functional programming is a language feature, right? But reactive extension or programming paradigm, how you going to use existing frameworks to change your language into reactive support language, right? So Java is object-oriented programming. Java has functional programming after Java 8. Now, when you started using Reactive X into your application, then your application going to be reactive. So this Reactive S providing many other implementation language, RX Java, RxJS, Python, Ruby, many more. There is something called Project Reactor, which Spring is using. Spring is a framework for Java, and we can have some other language also. But yes, so Groovy uses Spring, but I'm going to show here only for Java. And Akka is another framework, is so popular in the reactive world. It's Akka actor-based framework. It's not thread based, it's actor based. Actor is so granular level of what thread is doing. And Java 9, right? Java 9 Flow API. Flow is a new API which supports reactive programming, but it's an interface. And something called Small Ray and Vertex or other frameworks which popular in the industry. All said, one clue what I would like to give here is like, when something introduced in Java, right? That means it's a future. Why? Because this all framework started implementing by 2014. After 2014, all these frameworks started implementing this concept. Very late, Java came into the picture by Java 9, right? 2 years back, approximately two years back. He said, hey, I have a Flow API. It's an interface. You all going to go and implement. So now still you're going to use Reactive X, but Java 9 provided an interface, means it providing a standard. They are approving that this reactive programming is good. So I will start adapting to my language. That's what Java is doing. Okay. Reactive stream. Okay, what is reactive stream? I was talking about reactive stream. Reactive stream. This reactive stream is a unit who brought all this API. Java Flow API has publisher, subscriber, subscription, processor. Hope I don't want to explain what is publisher and subscriber. It's self-explanatory. But subscription is what, when I ask a publisher to give me when I subscribe to the publisher, he give me some subscription. It's kind of a token to you. You can use that token to get me more data, right? Give me. They will give you. Processor is a kind of intermediate. He will act as a publisher as well as a subscriber. It's a middle. You can use the processor to couple between a publisher and subscriber. When subscriber is looking the processor, it is a publisher. When publisher looking the processor, it is a subscriber. Hope that explained. Okay, so reactive stream, pretty much explaining the same concept here in the slide. Publisher gets the call from subscriber. Then on subscribe method, he is giving the sub, which is a subscription. With that subscription, I'm calling, give me 1, give me 2, give me 3, right? He will be giving all my data. I can say like, what is my capacity? I can say like, if you give me 5 amount of data, I can easily handle. If I say on next I1 or I10, right? He will be giving me 10 results. There are different channels, which is called data channel, complete channel, on error channel. This is a big difference between other stream and a reactive stream. So data stream going to receive data. Completion stream is going to say like you're done. Error stream says, hey, you got some error. Do you want to recover from it? That's what the data or error stream, how it being differed. Okay, so reactive stream. Okay, sorry. Reactive X is any question? Okay, let me continue. Reactive X is a popular framework which done this reactive, right? You guys will be curious to understand who created the reactive X, right? So Netflix. Hope you all having a good experience with the Netflix streaming, right? Their streaming is enormous. When you have a big screen, still they are streaming in a good quality, right? If you are a geek, you'll be so curious like how he did it, right? Might be I'm not giving the right or complete architecture picture, but it's one big piece is like reactive stream is a one framework which Netflix is open sourced, right? Their secret. Flowable from iterable. Iterable is a list we are getting, and I'm something adding a wrapper. As we seen ice cream example, I'm adding some wrapper to the ice cream order. Then if I started subscribing, all this data is considered as a stream. As Radhakrishnan was telling, the stream means Akshaya Patra, right? The infinite number of data you can receive. So hit here. Here subscribe means the data system.out.println, what here it's receiving the data channel, E expects the error channel, and this empty or unit explains the completion. It says done. Consider data is nowhere different from the error, right? Error is also another data. You are clicking mouse every minute, right? One of the minute you missed your mouse and you wrongly clicked the right click, right? That's kind of an error. I did not expect that even. That's also data. It's a streamlined data. So I'm just explaining what is add wrapper here. Here in this add wrapper, I'm throwing error. If there is a gray cone comes in, I'm throwing error. No stocks available. So how he finally going to handle this in this error channel? Okay, so now move on to a next different framework, which is called Akash Stream. This is created by Lightbin company, and they are the backbone for Scala. Here, if you see, it's something different. It's a source and it's a sink, right? He is the publisher and he is the subscriber. The terminology got changed, but what it do is the same. You see, map, reduce, map contact, everything is same. And actor materializer is something what distributed ACA cluster, right? So it's not now like your application going to do the business logic. You can set up some ACA cluster. You can submit this task to the ACA cluster. ACA cluster will give you more support on to process the request. So why is that need in this industry, right? Because scalability is the biggest problem here. We have a cloud, but people don't know how to write code which is easy to scale. Microservice is the one solution. Reactive is the toppings on top of microservice. So actor materializer you can utilize to get more scalability. Okay, here it explains what is stream, which is released by Java 8. Now Java 9 has a stream, which is reactive stream. We are not sure what more going to come. Now it's Java 14, right? Java 15, don't know what going to come. Even a lot of other frameworks we have. I'm talking about only Java here. Okay, so Java 8 is very poor to handle exceptions, but reactive stream handle errors in a finer way. That's a big difference between Java 8 and reactive. Data flow is pull based, but here data flow is pull versus push based, right? When you ask, it's a pull mechanism. When I give you talk, it's a push mechanism, right? This is what different something I can highlight here. Um, okay, give me a minute. Oh, I was just checking time. Okay, sequential versus parallel. You can parallelize your Java 8 stream, but in reactive stream, you can make it asynchronous, right? No more sequential or parallel talk. Here it is whether you're doing asynchronous or non-blocking IO. Some of you already heard about Node.js is handling all the threads with a single thread, right? Node.js is completely non-blocking IO, right? You can write better code using Node.js, right? Even poor developer can write poor bad code, even better language it is. Right? I'm saying here non-blocking, right? That means you are not blocking your threads. Let me bring something more spicy on it. You have a microservice, right? You have a Uber, you have an Amazon, right? If you're adding a one order, submitting or one order, they are doing multiple tasks in the background. They are doing your order check. Now the delivery location, if you're in Chennai, they are delaying the delivery, right? If you're out of Chennai, then they are delivering, right? Who makes these decisions, right? There are back-end process, back-end engine who's continuously monitoring all these things, and they are giving some credibility credits also. Like if you are doing some good what that we have something called Flipkart having the coin mechanism, right? Who issuing those coin mechanism? It's not on the fly when you order. It's on the time when the order is already submitted. The background, there are multiple tasks or jobs are running to validate your order, whether you completed your transaction, your address correct, your previous transactions, all these things are taken into picture. And sometimes even credit card, right? Credit card detail also they are processing. They are identifying whether your card is expired or not, and they are intimating you that your card is going to expire, right? It's bank's job, but even order processing they are handling. These many tasks are handled by backend engine. How it is possible? It is possible with the help of microservice architecture. Okay, now you are making an order from a UI, front-end application. Am I going to block the thread, single thread, which is communicating far away from the order processing? There is a X mission, Y mission, Z mission, right? So if I giving call from X mission, I'm going to block Y mission to until I get a process or data result from Z mission, right? Are we using right mechanism to utilize the maximum resource, right? No, we are not using. We are blocking threads and we are being idle for the time when the third machine completes the process. So this is where non-blocking is needed. Don't worry about that guy, whether he's giving ready to give the data or not. When he ready, he will give you asynchronously. So you start processor. Hope that explains. Okay, let me come to next good concept, which is called back pressure. Right? When you back pressure, it can be easily explained, but let me read this definition. Publisher is not allowed to send elements even now new ones are ready until subscriber able to handle the load. Right? Consider I'm talking now very fast, 2x fast, right? If you are not able to listen or understand what you will say, like, hey Ranjit, please slow down. I'm not able to hear you. Your voice is not good. Can you slow down? So I'm going 1.x, 1.25x, and 1x. Now you are saying it's good pace, Ranjit, go ahead. I'm going in the same pace. That's what the back pressure it is. When I am running out of data, I'm telling you, hey, give me data. That you start giving me more data, right? That's a good communication between subscriber and publisher. It's time to check my time. Yeah. Okay, that well said about like I would like to add one point here, like as it is NLP webinar, I would like to add something into my demo. So before I jump into demo, I would like to explain what is NLP. This is nowhere related to reactive. NLP is a different uh, stream, or okay, let's move out of stream now. Okay, it's a different unit or the department under ML, right? Machine learning, AI. So NLP, I'm going to use a sentiment analysis. NLP has a lot of other things. What Radha was doing was a lemma, right? He was doing a lemma on his demo. I'm just doing something different, a sentiment analysis. So what it is? Populate sentiments of crisis management, service adjusting, and target marketing. So this is some good. We have a good example like when you have a feedback, when you are searching for a location in Google, it will give you two options: the top criticized comment and top star comment. Right? How he is identifying, but that is criticized. It's a sentiment analysis. Okay, so predicting the success of the movie, predicting political campaign success, as Radha was explaining about that Trump, all these things, decide whether to invest in a certain company, targeted advertising, and review product and services. These are all some of the good use cases where the sentiment analysis playing major role and revenue. Let's move on to next slide. Live stream demo. Yes, I have a application. I coded for this talk. Let me show, before I jump into that code, let me show you what it is, what it's going to do. I was just curious to understand how many people are so negative or so positive about COVID, right? So I was using a Twitter stream to analyze the hashtag COVID-19 to see whether people are recovering it out from that, or they are so negative.
Feedback one day எல்லாரும் கேட்டுட்டே இருக்காங்கல.
I'm sorry. Okay, so was it to me? Okay, I don't think so. Okay, live stream demo. Here I was doing that, like if you see here positive, it says like this message is positively tweeted, and here it is negatively tweeted. There is a neutral also. This is what I did, but it's not the old way, like you persisted some data in a database where you are retrieving. It is a live stream of data. You are creating the live data from the Twitter, applying the sentiment analysis, as I said, the function on a stream, then you are persisting into database. Let me show another example, which I'm not going to cover. It would be helpful to visualize what I'm going to tell, right? So if you remember using Twitter, in Twitter you have something called who to follow. When you close one tweet, or sorry, one recommendation, that other recommendation will be automatically filled, right? Who is ready, right? So you are ready to close and infinite. You don't think like you can go get run out of this recommendation, because this is stream of data. Infinite data is coming from the Twitter, which is whenever you close it, there is another data populated in your Twitter and pushed to you. So that's the smart how a computer or the applications are serving us now. Okay, tweet hashtags. I'm going to render live stream data. So if you guys are having mobile in your hand and ready to tweet something, go and tweet hashtag SRM, hashtag Tamil computing and NLP webinar. Your time start now. So you can see your name into tweet. Okay, live stream demo, how it going to work. There is a Twitter API servicing some tweet to receiver. The receiver is in my application. There is MongoDB database which is inserted into the tweet. The tweet is inserted into the MongoDB. Then I have a WebFlex, another reactive application or reactive framework which establish the API to the React JS based event streaming application that I wrote. Okay, all set. Let me show a demo. Hope you all see my screen, or let me start share. Are you guys seeing my screen? I don't think so.
We were seeing your PPT only.
Okay, yeah, thanks a lot. Thanks for confirming. I'm now sharing the desktop. I'm pretty new to Zoom. Great. Okay. So you see here reactive stream analyzer and reactive stream viewer are two different applications. This stream analyzer written in Java with Spring Boot and Spring WebFlex reactive framework. Here it is written on React.js single page application. So I'm going to start this first, right? So I'm going to use Java-jar, my jar name, and SRM, Tamil Computing, and NLP webinar. When I start this one, this is going to start my native container to expose my application. You will have all this source code available in GitHub. I will be showing next slide where you can start download that. Okay, now I'm going to start my UI application. I'm sorry, right? I'm going to start my UI application. Hopefully, I'm not receiving any tweets yet. I believe I'll be receiving something sooner. Okay, you all able to see my screen? That's showing the browser. Right. If you see here, it says the message what I tweeted 10:13, right? So that time NLP webinar is streaming now on YouTube. So if you guys are, yeah, it's great, right? It's always my friend who Radhakrishnan helping me to do a better demo. Thanks, Radha, once again. So he tweeted some message with SRM Tamil Computing. It picked that one. There is a filter I'm applying on the stream. That filter is called SRM Tamil Computing and NLP webinar. It says all neutral, right? It means there is sentiment analysis framework which I use from Stanford University. That's giving me a score, sentimental score. If you see, like it's all words, right? It's nothing excitement word like very very happy or it's too poor, right? It's nothing, right? So that's why you are getting natural or a neutral response here. Okay, let me show something else that, okay, so I'll be showing the code base. Before that, I'll confirm how much time I have. All right, I have 44, I have 1 more minute or half more minute. Okay, I was getting one more message from someone else. I would like to thank him, Mr. Ramji. Thanks, Ramji. Okay, so what application it is? It's a Spring-based application, so that tweet stream application you can see here. I'm exposing this API as a text event stream, right? Text stream event stream is something different from application JSON, right? This is live stream. So I'm making some different here. Stream/tweet means I'm going to give you a message when I got. I'm going to give you event data whenever I got it in my database. So it's something called server sent event. This is also nothing new, right? It's an old technology. Event source in a JavaScript is old one, right? It's not new. It's a server sent event. If you guys know something about WebSocket, you will be having a question like, then what is different between this event source and the WebSocket? WebSocket is a duplex, right? It's good for gaming technology. Now PUBG, now we have Free Fire, all these things are so interactive, right? People are talking when they are playing. Who thought when you were running 96 games, right? Yes, obviously no, not. Now it's more interactive. That WebSocket playing a major role. Now this is event streaming. That server will be giving a data to you. You don't want to request every time. Again, it is running on top of HTTP, simple HTTP. It's no more expected like so. There are HTTP 2.0 persistent connections is also there, but this event source is still working on HTTP TCP layer, right? Okay, so that's it. Like here, a tweet bot. What it do is like, you see authorization. I'm giving my Twitter authorization to the exchange filter function that will apply to the URL what the Twitter API exposed. So I'm listening to the Twitter and I'm saying what is the method. I'm giving some map, right? This map is what this flags or the filters, right? The reactive filters. If you're not giving anything on the runtime, it will be using reactive. As I was giving SRM and webinar, NLP webinar, it is pushed to here and called Twitter API. So Twitter API responded all this information, right? So this finally saves. Twitter repo is a reactive based repository pushed data to my MongoDB as a subscriber. I'm subscribing to live stream and I'm pushing all my data to MongoDB. Whenever MongoDB finds data, he will be giving the data called find with tailable cursor by. Tailable means, right, whenever the data ready, he will be pushing. So this information is could be useful for you guys when you are experimenting how to write reactive programming. So there, I'm stopping my demo. Thanks for, I'm not able to read the name, Regato. Okay, now I'm going back to my slide. All said, if you are living in 2016, yes, you have some time to wait for reactive to boom, right? But you are living in 2020. You don't have a time to learn reactive, right? It's there already. All other applications started implementing it. So go and learn reactive. Happy learning. And external source where you can see like reactive streams and reactive manifesto are the two keywords. You can go for Google and you can find more links on it. And this is a short URL. You can find my source code, or you can go to ranjithraj/reactive stream to identify my demo project there. You can free to star, fork, contribute. I welcome you all. That's end of the session. I believe I stop. I can, yeah, I'm over. Yeah, thanks a lot. Q&A, please ask your questions. I'll stop screen share here. Thank you.
Participants, if you have questions, please ask the presenter. Ms. Nirmala Ranganathan, you had a question, right, in the chat box. Can you just post it now? Can you just ask it right now?
Okay, let me see.
Yeah, she had asked about a single example. I will let you know.
Okay, Ramji was asking one question. Ramji was asking question like, from your GitHub, can we have a coding in Python? I'm not sure. Okay, so you are asking like how the same code you from Java to Python, what you are expecting. No, it's not available now, but it's just an implementation. it's not ready now. I welcome other participant who can try to contribute on the code base. I welcome you all.
Yeah, and Ranjit, Nirmala Ranganathan has asked, can you give a scenario for specific propagation of change in our reactive programming? So that was her question.
Okay, let me give you. So I initially gave one example. Consider you are using your application, the Facebook application. Your friends are tweeting, or sorry, friends are posting something on their timeline, right? That's a change. How you are related to that change, because it's your friend, right? Your friend is posting something on his wall. That change is propagated to you. You are listening to a stream. As you are started using application, mobile application of the Facebook, you are started listening to the stream. All the data are you are receiving. You remember you normally used to click one of your friends post, right? In that case, you will be receiving more on it. Who is applying those filter, right? Those stream, your application is applying the filter. Whenever I have Mr. Radhakrishnan tweet, give me more, right? So the stream is like that Radhakrishnan or someone like, yeah, we have something called Kritiya Devi here, someone called Kritiya Devi, all these persons are adding their post on their timeline. Those are considered as an event. I'm listening to that event stream. Whenever I have a filter that Radhakrishnan tweets or posts are important to me, that will be delivered to me. Hope that answered, or we can have more discussion in the chat space.
Yeah, and Sunita Devi has asked about optimization algorithms for NLP. If you can answer it, like.
I'm sorry. Yeah, so that's a disclaimer I had initially. Yeah, NLP. I just included how to apply it on the reactive application. I'm not having idea more about NLP, right? My area is a reactive programming and data processing. I included here for this webinar. Maybe you are asking a wrong person. Sorry about that.
Okay, thank you. So is there any other questions from the participants? You can post
Ma'am,
in the chat box.
one more question.
Yes, ma'am.
Dr.
Yes,
L. Dr. L. Srinivasan sir asked, ma'am.
okay, ma'am. What was that?
Sir, how far NLP can be used to identify an author of a mail?
Yeah. I think.
So if someone author of the mail, I'm sorry, I'm not well versed on that topic. My topic is covering the data processing with the reactive. So let me try some experts here. They can answer on this one.
No, I think Dr. L. Srinivasan sir, your question is like, what is the latest and efficient algorithm for authorship identification, right? So that is the, authorship identification. Ranjit, can I talk on this?
Yeah.
Yeah. So authorship identification, like it depends on the various factors, like the style of authors. Each and every author will have their own styles. They will have their own set of keywords or words usage. So based on that, you can look that as a classification algorithm. Maybe you can use any supervised algorithm you should be able to use. Did I answer your question, sir? So that is about authorship identification as far as I know. Yes, okay. So any other questions? Okay, if there are there are no any further questions, like we can end the session. Thank you so much, Ranjit. Like it was very interesting session. You gave us a live demo as well. It was really helpful. I'm very sure like participants would be able to dig more on this reactive programming further. And for the participants, Ms. Anita has posted you the feedback link. Please fill it. And for tomorrow, we have to meet at 9 a.m. in the morning. I know it's a bit difficult, but the speaker is speaking from San Francisco. So to help him out, we have fixed this timings. So let's all meet tomorrow at 9 a.m. to to learn about Tamil computing and its state of the art, current status in the research arena from Dr. Muthu Annamalai speaking from San Francisco. Thank you so much, speakers, and thank you so much, participants. You've made this day a wonderful, one. Thank you so much. Yeah, Ranjit, do you have anything to say?
Sorry, I'm sorry. There was one question from Jagatish. He was asking like more about Java 9. Okay, so please follow me with LinkedIn. I used to post some of lot of these kinds of interesting area. So you can reach me there, or you can directly message me on the LinkedIn, or you can go to GitHub /ran RAJ. So where you can find more of Java 9 or other technology like Spring, some Rust-based applications available. My code are available, so we can more interact and work collaboratively. Thanks for your patience.
Thank you so much, Ranjit. Yes. So with this, we are ending the day one session. One dimension we have completed, that is on data processing from the industry perspective using Kafka and reactive programming. Thank you, participants. We'll meet tomorrow to learn about Tamil computing and its current status in the research arena. Thank you all. Please fill the feedback link, and then we all can leave. Yes. I think I've changed the settings for feedback. Now you should be able to fill the link. Are you all able to fill the feedback link?